Lesson 1.6 Classify polygons. By the end of today's lesson, we will be able to successfully identify polygons and their properties. In geometry, a figure that lies in a plane is called a plane figure. A polygon is a closed plane figure with the following properties. Number one, it is formed by 3 or more line segments called sides. Each side intersects exactly 2 sides, one at each endpoint, so that no 2 sides with a common endpoint are collinear. So this means that if you have a triangle, no 2 sides with a common endpoint are collinear. Each endpoint of a side is a vertex of the polygon. A polygon can be named by listing the vertices, plural for vertex, in consecutive order. So what this means, I can name this polygon to the right as A, B, C, D, E, or D. I can begin with D and move to C, to B, and then to A, and then to E. And they are both correct names for the polygon to the right. A polygon is considered convex if no line, so let's say this line here, that contains a side of the polygon contains a point in the interior of the polygon. So if I draw these 4 lines, they will never contain any points inside the polygon, versus a polygon that is concave. If you have a concave polygon, if you were to draw a line through this side, as you can see, you have points intersecting the interior of the polygon, and we don't want that. Now that will be considered concave. Okay, example 1. Tell whether the figure is a polygon or whether it is convex or concave. So for the first picture here, if you extend any of the sides, you'll see that the line will not intersect any of the points inside the interior of the polygon. So we will call this at first, yes, it's a polygon, and we will call it convex. And for the other one, if we extend this line, it's going to intersect the interior of the polygon. So we're going to call this concave. And the next shape, convex, because all the sides will not intersect the interior of the polygon. And for this fourth figure here, it's actually not a polygon because it's curved. So you don't have to worry about identifying it as convex or concave. Okay, so now we have naming the types of polygons, and we're going to begin with the most basic one, the triangle. And with 3 sides, with 4 sides, we call it the quadrilateral. And then the pentagon, hexagon, 6 sides, and 7 sides, heptagon. And with 8 sides, octagon. 9 sides, nonagon. 10 sides, decagon. And with the figure with 11 sides, we call it a hendecagon. And with 12 sides, dodecagon. And a polygon with n sides, we call it an n-gon. I will be expecting you to know all of the names from triangle to dodecagon, and any figures above 12 sides, then we'll call it an n-gon. In an equilateral polygon, all sides are congruent. In an equiangular polygon, all angles in the interior of the polygon are congruent. A regular polygon is a convex polygon that is both equilateral and equiangular. So let's just look at a simple polygon such as a square. So all sides of a square are considered equilateral and all angles are equiangular, 90 degrees. So we say a square is regular and also convex. Example 2. Classify the polygon by the number of sides. So for the first one, we will call this a hexagon. Tell whether the polygon is equilateral, equiangular, or regular. Well, if we look at the picture here, we have the little marks. This indicates that all sides are equal. And then the little arcs. This indicates that all the little angles, or all the angles, are equiangular. So we can say that this polygon is, or this hexagon is regular. For part B, we will call this a quadrilateral. And not all sides are congruent, because here we have one pair of congruent sides and another pair, but a different length, and also two different opposite congruent angles. So this quadrilateral here is not regular. And then we can say for the next figure, part C, this will be a dodecagon. We got 12 sides. And if we were to draw a line through one of its sides, well, it's going to intersect another side too. You can see that this point will intersect the interior of the figure or picture, so we would say that this is not convex, so not regular. Example 3. The head of a bolt is shaped like a regular hexagon. The expressions shown represent side lengths of a hexagonal bolt. Find the length of a side. So since this hexagon is regular, I'm going to set two sides equal to each other. So 5x minus 1 equals 4x plus 3. Then x equals to 4. So I can take any of these expressions. I'll take 5x minus 1, so that'll be 20 minus 1. So one side is 19 millimeters. Now pause the video and try example 4 on your own. And then when you are done, continue to play the video for the answer. Now double check your answers. And we will continue the lesson in class.